This is Mrs. Holbrook again with the third part of Chapter 7 review that we are doing for our basic STEM class. And we're continuing to talk about parts of similar triangles and using a lot of proportions in this situation. So we've got a lot to work through, and they use a lot of fancy math talk, but we're really not getting into a lot of that. So, main ideas: recognize and use proportional relationships of corresponding perimeters of similar triangles. Again, proportions of perimeters. Yeah. If we have similar triangles, the perimeters are proportional. Same thing with angle bisectors, altitudes, and medians. If the triangles are similar, all of those parts are proportional. Okay, so there's again all the fancy math talk. And here's our first example. They're telling us that these two triangles are similar. So right up here, let's see if is it going to move? Oh, it's not going to work that way today. Okay, so they're showing us right here that the two triangles are similar. Triangle ABC is similar to triangle XYZ. AC is 32, AB is 16, BC is 16 radical 5, and XY is 24. Find the perimeter of triangle XYZ. Well, the only number we have over here is 24, so I know we're going to deal with this ratio 16 to 24 when we set up our proportions. Okay, so let X represent the triangle or the perimeter of triangle XYZ, and the perimeter of ABC, we just add all three parts there together. So 16 plus 32 is 48. And then they left this 16 radical 5 out there with 48. So 48 plus 16 radical 5. They didn't turn this into a decimal. If you wanted to, that would be fine. I could accept either way. So segment XY to segment AB is proportional to the perimeter of triangle XYZ over the perimeter of triangle ABC. Hey, that went too far. Go back. Okay, so now we plugged in our values. 24 to 16 equals X over the perimeter of the other triangle. And we do some cross multiplying. Multiply that out, and we divide each side by 16 to get 72 plus 24 square roots of 5 equals X. Is it a pretty answer? Nope, but it's the answer. We could again turn that into a decimal and that would be fine. So here's one for you to check. And again, I need to see the proportions that you write. I should see your cross products, and I should see the final answer that you come up with. Now, if you don't want to keep the square root of 2, this means multiply 20 times the square root of 2 so you can turn it into a decimal, but then you'll need to compare each of these answers as decimals as well. So again, we know that this segment PN is 6, and this segment XQ or QX is 20, and we're looking for what is the perimeter of triangle PNO, and it does tell us that they're similar. So you may need to pause this for a minute so that you can do your work. Okay, here's a whole lot more math talk, but again, the idea is the same, that all these fancy parts that they're talking about are proportional if we have similar triangles. So this piece here that they're drawing from one angle to the opposite side and it makes a right angle is called an altitude. It's one way to find the height of a triangle if you're working on formulas for area or anything like that. So this is called an altitude. And if we know that these two triangles are similar, this piece here, these altitudes, are proportional to each other. In this picture, they're showing us angle bisectors. So this line cuts the angle into two congruent pieces. The line comes up, cuts the angle into two congruent pieces. So this line QB is proportional to this line UX as long as the two triangles are similar. And down here at the bottom, this is a median. And again, it looks almost the same as what we have up in the other two pictures, but notice it splits the opposite side into two equal pieces. So again, median QM and median UY are proportional if the two triangles are similar. That's what all of those rules are saying. So whether we have altitudes, angle bisectors, or medians, if the two triangles are similar, the sides or those pieces are going to be proportional. Okay, we don't write proofs, so we're going to skip through this, but we can do this question. Now, I'm going to tell you right now, to me, this is almost a trick question. They're telling us triangle EFG is similar to triangle MSY, and that segment EF is equal to 5/4 of segment MS. Find the ratio of the length of a median of triangle EFG to the length of a median of triangle MSY. So keep in mind that the two triangles are similar, and parts, corresponding parts, or parts that match up in similar triangles, are proportional. So this one, there's really not a lot of math work to do. So probably what you should write down is just this very first part. Triangle EFG is similar to triangle MSY, and EF equals 5/4 MS. And then use that to help you decide your answer. Again, the key there is remembering that all of it is proportional. Okay, here we are with another example, and we're talking about medians. So remember, a median divides the opposite side into two congruent pieces. So even though they're not marked, I know that DG is congruent to GF. I know that IL is congruent to LK. So here they tell us that the two triangles are similar. EG is a median of triangle EFG, JL is a median of triangle JKL. We need to find JL, and again, I really wish this would give me my ink tools. Let's see what this does. Hang on. Hey, we'll see. Okay, so we need to find JL. There's my X. If EF is 36, I'm writing with a mouse, so I'm sorry it's not beautiful. ED is 18. What do you mean my handwriting's never beautiful, mouse or no mouse? That's not very nice. And JK is 56. Okay, so again, I label all of my parts and pieces, so now I can see pretty easily that my 36 and 56 are corresponding parts. Did I label my 18 wrong? ED is 18, EF is 36. Interesting. So it's labeled correctly. I just double checked that, and let's see what they do as we move on. No, I don't need my draw tool now. Oh, it went away. Okay, so let's see what happens next. So we're going to write a proportion. 18 over x equals 36 over 56. Because EG equaled 18, JL was our x, EF was 36, and JK was 56. So we cross multiply, and 28 equals x. So they're saying JL equals 28. Okay, I'm going to be a bad teacher and go back. JL was 28, JK was 56, EF was 36, and ED, this is a typo. I don't think they didn't use ED as 18. They used EG as 18. I'm going ahead now. I'm going to find out. See here, EG, 18. So they made a mistake in their PowerPoint. So if you drew this picture in your notes, please fix that. Okay, here is a place for you to check. Now we have AC is an angle bisector and MO is an angle bisector. And we know that, let's see, AC is 5, so this piece here is 5. AB is 7. MO is 12.5. 12.5. This yellow color is kind of nasty. All right, 12 point, make that a big point, stop it, 5. And there's our X. So you should be able to set up a proportion now because we have all the right pieces labeled. So we've got 5 and 7, 12.5, and X. So again, I should see your proportions, your cross products, and your answer here. Here's another problem that you'll see with similar triangles. Here we have two poles supported by wires, so that we know that triangle ABC is similar to triangle GED. AF is congruent to CF. FG is congruent to GC and congruent to DC. Find the height of the pole EC. So again, we are looking for this right here. Well, looking at this picture, I know from A to C is 80 feet. So I've got a proportion with my 80 and my 30. And I know from G to D is 40 feet. And how much does that leave for X? So again, we'll probably set up, let me get this gone so I can keep going. They'll set up their proportion. There's a bunch of explanation. Okay, so we know that GD is 40. So 30 over X equals 80 over 40. 1200 equals 80x. Divide by 80, and we find out that X is 15. Okay, now I saw right here that 40 was half of 80, so I figured that X was going to be half of 30, which was 15, and it worked out as well too. Okay, so the height of the pole is 15 feet. Here is your last question to work on, and you may, I want you to put this drawing in your notes and label your parts and pieces. So AC and GC are legs of a table. The top of the legs are fastened so that AC measures 12 inches. So from there all the way to there is 12. GE from there all the way over measures 36 inches from there to there. BD measures 7 inches. So what's the height H of the table? Now, trick question, you guys here. You have to set up the proportion to solve for X. Oh my goodness, that's a beautiful X. But once you find that, they want the whole table. So we're going to have 7 plus whatever you find for X. Okay, they're representing this whole height. So make sure you figure that out. Let me hide this thing here so you can see answer D is 28. So sorry that disappeared. You can back it up if you need to. And I apologize that this is a 12-minute video. So this is the end of Chapter 7, Lesson 5, just keeping in mind that parts of similar triangles are proportional.